We're given another system of equations. It has variable s and t. We'll think of those like x and y. 2s minus 3t minus 9 is equal to 0. And the second equation is negative 6t equals negative 4s plus 1. We're going to solve it using Gaussian elimination. So we're going to use the same steps that we used before in note 126, which means first we are going to translate into the augmented matrix. Now, before we can do that, we have to line up the s's, line up the t's, line up the equal signs, line up the constants. So this is 2 times s minus 3 times t. Bring down now the equal sign, and the 9's on the other side. We add it to both sides. It becomes positive. Then the second equation, bring over the 4s, makes it positive when we add it to both sides, minus the 6t equals the constant 1. There's our system of equations where everything is lined up. Now let's go to the augmented matrix. We have a 4, and then a coefficient negative 3, and then the 9. And below that, oh, I'm sorry, that wasn't a 4. That was a 2, wasn't it? A 2. Below that is a 4, a negative 6, and a 1. And if you want to, you can put the dotted line, not necessary. This is row 1, and this is row 2. Okay, first we're going to start on the upper left corner, making that 2 into a 1, because we're working on getting lower triangular form. That's step 2. It takes a little while to do this sometimes. Now here's the plan. Making that 2 into a 1, I've decided to do 1/2 times row 1, and that result will replace row 1. Okay, so this will be the result. The new row 1 will be, and you do the work on the side, I'm not going to show it, you can do it, 1, and then space, and then negative 3/2, and then space, and then 9/2. That's the result of negative 1/2 times row 1, replacing row 1. Now row 2 is unchanged. It's got a 4, a negative 6, and a 1. So there's my new row 1 and my row 2. Next, I'm going to concentrate on getting this dude down below to be a 0. So to do that, I have decided to do negative 4 times row 1 added to row 2, and then take that result and replace row 2 with what we get. Okay, now without showing all the work, this is just the result. I'm replacing row 2 only, and I'm going to have the row 1 unchanged. 1, negative 3/2, positive 9/2. That's my row 1. And then row 2 is the result of the operation I just did in my head, or on the side somewhere. I get 0, and then another 0, and negative 17, and that's my row 2. Now, it gave me more than I wanted. I was only trying to make the negative 4 in the lower left corner become a 0, but it also gave me a 0 in the position beside that one. And now I'm worried because I can't get lower triangular form, so I better stop at this point and analyze what I have. What is this system? So what does this look like now? Let's translate back and see what it looks like. It looks like 1 times x minus 3/2 times y equals 9/2, and 0, 0, so it's just 0 equals negative 17. So we're stuck here with this, we lost all of our variables, and that statement is never true. So I'm just going to note that. This is never true. When we lost our variables, we were stuck at a statement that's never true. That implies that there are no solutions to this system. See? Because we lost our variable at a place that gave us 0 equals negative 17, and because that just doesn't make any sense, it's never true, we conclude that there can be no solutions to the system, so our answer is empty set. And remember, when you have no solutions, your system is called inconsistent. Just a reminder, that's the type of system we have here, and we are finished.